Hello everyone, my name is Devin, and today we will analyze Mission Impossible scene with physics, concepts, and also principles.
Can you open the
That
door?
topic is Mission Impossible, and the
Ethan?
scene is
Lori,
scene.
I'm by the
Best
plane.
scene
Becky,
is
can you
impossible?
open the
No,
door?
it's
Can I
impossible.
open the door?
Which
Maybe.
physics concept
Open the door when I tell you!
For this project, I wrote 5 hypotheses. So the first one, if human jumps from a hill into a plane, then most likely the human will not able to reach the plane. The second one, if human wants to catch a moving plane by running from a hill, then the person must have a big amount of power, energy, and work. The third one, if humans try to walk on the plane's wing, then fluid mechanics allow them to sink or fall. And the fifth one, the last hypothesis, if humans try to go behind aircraft engine, then they will get blown off because of the heat and sound waves that is dangerous for them. This is the information table, a short brief history of the main objects in the scene, which is the C-130G Super Hercules, and also the human, which is represented by Tom Cruise in the movie scene. Below there are object mass, velocity mean and max, and also speed mean and max, condition, force, and the outcome. You can take a look for the speed, the velocity, the condition, and the force that is applied during the scene. So moving into the first concept of physics, which is Newton's law of motion, here I drew 3 free body diagram with different types of condition. The first one is when the human, Ethan, which is the character in the movie, jumps from a hill. The second one is where he stands on the wing, and the third one is when he bolts into the plane's door during takeoff. So below it, there are some Newton's law of motion equations and also solutions. So you can take a look from that. So the friction force, the gravity force, the applied force, the normal force, and also the sigma fx and also sigma fy. You can take a look. And for the conclusion, the movie scenes managed to get it all right, because again, for these principles, it's only proving the Newton's law of motion force. So far so good. The movie get 1 point from the physics concept. Moving on into work, energy, and power. Here I calculate each of the work, energy, and power. So start from the work. Work equals to force times distance. Force when you run is 3 times your body weight. So as you see before on the information table, Ethan's weight or Tom Cruise weight is 68 kilos times 3 equals to 204 newtons. Distance of a small hill is 30 meters and width of the runway is 45 meters. Width of the plane wings is 40 meters. The gap between the hill and the wings are 5 meters. The total distance is 35 meters. And again, to calculate the work, we get the equation of 204 newtons times 35 meters is equal to 7,140 joules. And for the time is 35 meters divided by 6 miles per hour equals to 5.8 seconds. Okay, that is for the work. Moving on into the energy. Energy equals to half m mass times velocity to the power of 2. So again, if you see the information table, you can get this equation: half times 34,370 times 1,200 to the power of 2, and we get this number, which is very long. You can take a look. For the joules applied when running is 24,746,400 joules, which is not possible to spend during 4 seconds in the movie scenes. So again, you need more time to burn or to do that much quantity of joules. And for the power, the last one is 68 kg or kilograms, which is the weight of the human, divided by 5.8 seconds, which is 11.72 joules, which is too small to catch a moving plane. So from here, we can conclude that it is not possible. If human jumps from a hill to the plane, they need more time, they need more energy. And again, if we calculate the energy, you cannot apply that much of joules in only a short time. And for the power, I think you need more power. So far this scene get 1 out of 2 physics concept correct. Moving on into the fluid mechanics. Buoyancy. Okay, before we continue, maybe we can discuss a little bit about buoyancy. A solid body submerged in a liquid or gas weighs less than when weighed in free space. This is because of the upward force called buoyant force, which any fluid exerts on a body submerged in it. So, if the buoyant force is more than the object weighs, when the object weight, then the object will float, and if the buoyant force is less than the object weight, the object will sink. For the object that sinks, its measure weight will be less by the weight of the displaced fluid. The amount of buoyant force available to an object can be calculated by using the following formula. So F equals to PGV. So F is buoyant force, P is density of air, G is the acceleration to gravity, and the last one, V, volume of the object. So again, we can use informations that we can get from the scene. Average volume of human is 0.062 cubic meter. Density of gravity is 1000 kilograms per meters cubic, and also the density of air 1.2 kilograms per meter cubic. The buoyant force itself, we can input the equation based on the formula, and then we get 74.4 newtons. For the gravity force on human, again, the mass of Ethan is 68 kilograms times 1.2 kilograms per meter cubic equals to 181.6 newtons. Again, this shows that the gravity on human is greater than the buoyant force itself. Then, based on the explanation before, I explained that if the buoyant force is less than the object weighs, the object will sink. In this case, means that Ethan will fall from the plane. It will not float or stand still on the wing. He will fall out as soon as the plane gains velocity. Okay. The last one is wind and sound waves. This basically is just an explanation based on the theory that we know and based on the physics concept. A large jet-propelled aircraft can produce winds up to 100 knots as far away as 60 meters. Propeller wind blasts can be hazard to people or other unsecured objects behind the aircraft, and is capable of flattening buildings and destroying vehicles, and propeller plane fly over at 1,000 feet. For the sound waves, a typical airplane sounds about 120 decibels at takeoff, and a jet engine sounds 150 decibels until 165 decibels. So it means that if you stand or being in the back of an engine, both of propeller engines and also jet engines, you probably get blown, or maybe you can get pulled off because of the wind. And again, the sound that is produced by the engine is so loud, and based on the information and also the concept, if you get a certain decibels of sounds, which in this case is 120 decibels until 165, you can get most likely to ruin your ear, especially when you stand right behind the airplane engine. Okay, for the conclusion, rating 1 physics theory correct out of 4. As you can see from the previous calculation and explanation, this 19 movie on Mission Impossible only passed 1 physics theories between 4 of them, which I test. But then my hypothesis was proven correct because when you stand behind a propeller engine, you can get sucked out and your ears might hurt. And lastly, you can hold on it forever, which means you can most likely die in a few seconds. And 1 in 1,000 possibilities you can survive it. However, nature science won't let you do that. So I rate this movie scenes with PGP 13.